The first thing to keep in mind with limiting reagents is they're not scary. A lot of people see this and then they just freeze or they shut down. Limiting reagents is just figuring out if you have a certain amount of each reactant, which one are you going to run out of first? So let's take a look at the example that we've been using all along of nitrogen plus hydrogen yields ammonia. We've got the balanced equation. If you struggle with that, make sure you review that before you do limiting reagents or any stoichiometry. Here in this problem, we see that we have 17 grams as well as 14 grams. Both of these are reactants. So we need to figure out which one are we going to run out of first, and that's going to be our limiting reagent. Now, there are lots of techniques for doing this. I know some textbooks will show solve each reagent for each other and all those things, but ultimately we're going to need to know at the very end, at some point, we're going to need to know how much product we're going to get. So really an extension of this question that I have in front of us would be just to say, okay, how much product are we going to get? Let's go ahead and solve that. We're going to see 17.0 grams of nitrogen. But look at what I'm doing. I'm also going to put at the same time 14.0 grams of hydrogen. Now I'm just turning this problem into two separate stoichiometry problems. We're going to solve both for the product, so I'm going grams of nitrogen to moles of nitrogen. Then I'm going to go moles of nitrogen into moles of the product. Make sure that you're looking at the problem because sometimes you have two products. Make sure you pay attention to which product you need to be solving for. And also, if they're just looking for moles or just looking for limiting reagent, you might as well just stop at the moles. But in this case, let's take a look at what it would look like if we're going all the way to grams of ammonia. Okay, so I fill this in. 1 mole of nitrogen. Each nitrogen is 14, so that's going to be 28 total. If I look at the ratio, I see 2 moles of ammonia for every 1 mole of nitrogen, and then 1 mole of ammonia. We have 14 plus 3, that's 17 total. Okay, before I even pick up my calculator, I'm going to do this. Let's figure out now, do the same type of math, factor label method, and figuring out now for hydrogen. Okay, so we're going to go from moles of hydrogen into moles of ammonia. We're going to solve both of the reagents for the exact same product. Now watch what happens when we do this. NH3. Okay, so 1 mole is 2 grams. Looking at the ratio, I have 2 ammonias and 3 hydrogens. I have 1 mole and 17 grams. Now, if you look at the problem, you might be inclined to say that you're going to run out of hydrogen first because I have more nitrogen. I have 17 grams and hydrogen's only 14 grams. However, if you do the math on here, you're going to end up with, it's actually 20.64. Actually, that should be 20.6. And then 14.0, if I do that, I'm going to end up with, 79.3 grams of ammonia. Now what that means is, if it was up to this much nitrogen, I could only get 20.6 grams of ammonia. But if it was up to this much hydrogen, I could get 79 grams. I run out of my nitrogen first. That's the most ammonia that I can get out of this reaction. My limiting reagent is nitrogen. Okay? That's my limiting reagent right there. I have hydrogen in excess. Okay? So really, you just do the stoichiometry twice, solve it for the same product, and then you circle your smallest answer. The reactant that gave you that answer, that's going to be your limiting reagent. Now, let's take a look at how much of the other reactant is left over. We call that calculating excess. Same problem. We had hydrogen plus nitrogen yields ammonia. Okay, this was a 3, this was a 1, this was a 2. Okay, so we want to know how much excess when we reacted those two together. Well, if you look back, we saw that we have, let's just call it, let's see, the 17.0 grams of nitrogen. Let's just call this 21. And the 14.0 grams of hydrogen, let's just round that up nice and easy. Let's just call that 79. Okay? That's how much we got from that limiting reagent problem. Calculating excess just says, okay, what's the difference between those? How much hydrogen is really left over when I reacted? All of this nitrogen is all gone. How much of this hydrogen is left over? Well, here's what you do. Since I already calculated out in the previous problem how much nitrogen made and how much hydrogen made, let's subtract those two numbers. Remember, this is both grams of ammonia. So if I take a look at the difference between those, that's 8, that's 5, that's 58 grams difference. Okay? So what that truly means is if it was up to hydrogen, I could get 79 grams, but it wasn't up to hydrogen, it was up to nitrogen. So nitrogen only gave me 21. The difference between these two reagents is 58 grams. Now, let's solve it back. Grams of ammonia to moles of ammonia. Now, here's where we need to be careful and just kind of keep our head about us, because we have to remember what we're solving for. We're solving for our excess reagent. Now, in this case, hydrogen was our excess reagent. Okay, not nitrogen. That was our limiting reagent. We're going to solve it back for hydrogen. Now, we're going to figure out, okay, hydrogen, grams of hydrogen, we're figuring out how much hydrogen is left over. I took the difference. Now I'm going to go and work backwards to the excess reagent. 1 mole, we said, remember this was 14 plus 3, this was 17 grams. So we said this was a 3 to 2 ratio. 1 mole of hydrogen weighs 2 grams. Now if I do this math in here, what I'm going to find is I'm going to find a difference of 10.2 grams. That means I'm going to have 10 grams of hydrogen left over. I started with 14 grams. I only used roughly 4 grams in this reaction. So the rest is excess, it's waste, and that's what we want to try to eliminate when we're doing chemistry and doing reactions. We want to eliminate the waste, because what do you do with the extra hydrogen? So again, to sum up with excess reagents, I would suggest just taking the difference between the two products, converting that back to the excess, and that is going to be your excess reagent. That's how much hydrogen was left over.